Hi, we're back for part 2 of the big saltwater damage. 4 years ago, this phone went into saltwater on purpose. Kelli took it with her to dive down in the Caribbean on her Bahamas trip to see some cool underwater statue that was on her bucket list to take a picture. She had it in a waterproof, life-proof case. And it turned out to not be waterproof, and when she came back up, it was filled with water, and that phone never turned on again. And that was in 2016. And we spent a big chunk of time already, a couple days ago, on this phone. And we encourage you to go watch that stream, and I'll recap that a little bit as we start on this board. But what I'm circling back to it today, if you didn't see the first part, I just noticed that that the phone came to us in this little Ziploc bag that really spoke to me, because Kelli says, for my birthday, I want all of the photos and videos off this phone. And then under that, it says, left for my husband a year ago. Which is really funny because my husband is turning 50 tomorrow, and for his birthday, he asked me, the only thing that I want is for you to fix this goddamn microwave. So me and the girls spent a whole day over the weekend tearing apart this built-in microwave, which we did fix. Microwave works. He doesn't know that yet. So I get it, Kelli. I get that, like, the best thing that you can do for your spouse on their birthday is to fix something. So we're gonna continue on with this one. Now, I have limited time today, but I wanted to try to squeeze in this stream. So I'm going to show you where we are now. So let's take a look at where this board is. And I've done some work on it. I actually came back that night and put a little bit more time because I was just curious about something. When we left off, we were looking for why was this phone consuming 300 milliamps on DC power after we prompted it to boot. There was a short circuit somewhere, but we didn't know where. Well, I figured out where that was, and I'll show you. So let's take a look. If you're new to this board, let's recap. Here's the worst of the damage. On this board, the backlight driver, there's 2 backlight drivers. They're both gone now. But this one here actually fell off the board during ultrasonic cleaning. There's a large capacitor that lives there that's missing, and so are its pads. And you can even see a burned away of the top layer of the board. You can see the second layer traces. Remember, it's a 7-layer sandwich going underneath there. So that's a pretty big train wreck. I have now kind of cleaned it up a little bit. I went ahead and I desoldered this front camera bracket. You can see that I have replaced the LCD connector. The LCD connector was in really rough shape, so I went ahead and replaced that. I cleared out some of these guys to do some measuring around. You can see a lot of the damage. I went ahead and deleted the home button connector as well. So this was the majority of the damage on the board. You guys remember from last time that we had already ruled out Mason. There was significant corrosion there on the 1V8 line. We've taken off audio IC. Remember, I made this little bridge here, but they're both ground, so we didn't care. We noticed that the power management chip looked great, so it's unlikely that that's actually where the problem was, even though this is where the heat was showing up. We're not going to just see hot, remove hot, bro, because there's always got to be a mechanism. How did it come to be this way? On water damaged phones, the problem is where the water went. Water did not go under that chip, so that's really unlikely to be affected. All right, we've got a lot of bad looking stuff around the flash memory chip. We've already removed the baseband power management chip. And you can see that now I'll kind of walk with you through the repair process that you missed. It looks pretty good up here. And then we're back here to the beginning of this phone. So, what happened since part 1, where we were doing a lot of this cleanup? Part 1, we originally found and removed our first short circuit on backlight anode line, and then cleaned up some stuff, and we spent some time using this strategy to find where is the short circuit that was causing a 300 milliamp drain. And guess what? Shortly after I hit stop streaming, even before I took my son home, I found that short. And I'll show you how I did it. All right, so where was it getting hot? When we used the thermal camera, we could see that there was a little bit of heat by these 4 coils And we could see that there was a little bit of heat around the corner of the power management chip. And we could see one little bright spot under the chip with the thermal camera. We ruled out any short circuit on this power line here. This is PP CPU. And we measured voltage. It was correct. So we eliminated that. That's not short because it can maintain that pressure, that voltage. So what is a short? When we were on part 1, we spent some time looking around here trying to play a method that I call guess the ball. So the guess the ball method to figure out the short, we tried that a little bit and that ended up being successful. So let me show you what that looks like. If we head over to ZXW and just ask, hey ZXW, tell me what are the possible balls underneath the power management chip, maybe I can figure out which exact ball is creating that tiny little heat point, and that'll tell me what line. So we had said that we thought that it was getting hot somewhere in this range right around here. So we said maybe there's a short on this line, AP to PMU BLDWI clock. That's a good idea because that line goes right to the heart of the damage under the backlight driver, and it was really burned there. So we teased that apart, but that was not the cause of our 300 milliamp short. So what was? Is it this one? No, that one we already had ruled out. Is it this one? VCC main? No, that can't be because we'd already measured that. And so I kind of took the approach by just backing out, click, click, a little bit more. So we've already investigated all of the balls that are sort of around that really focal area. Let's just take a wider lens because we see a hot spot on the chip. Maybe it's not the ball under the chip, but where that circuit kind of goes through the corner of that chip. And I took a broader look. So I started clicking maybe here. What is this? TriStar. Okay, TriStar to PMU. That makes sense. Maybe it could be TriStar. And maybe it could be this one here. And let's see, which one was it? 3VO proximity. Maybe it could be this one here, 3VO Mesa. And that was the one that it was. So see right there, we saw that hot spot. We were just a shade over, so broadening our circle a little bit to investigate candidate lines that were a little bit further afield of that one point. Said maybe it's 3VO Mesa. So 3VO Mesa goes where? Let's find out. So from the power management chip, 3VO Mesa. Mesa is a word that means the fingerprint sensor chip itself inside the home button. So it goes out here to the home button connector. That's a really hot lead because right up here in that corner of the board, that's where the board was really kind of hard hit, right? Let's look at that area and see our possible candidates. Right, so this is one of the really ugly looking parts of the board. And indeed, this I measured with a multimeter is 3VO Mesa short. Yes, it is. And then why is it short? I deleted all of these guys that were, most of them just fell off, cleared out all of the silicone waterproofing and found that the cause of the short was actually under the Mesa boost chip that was right there. So removing that chip relieved the short. So then the short was gone. Next step, continuing on. What happened to a DC power supply after the short was gone? Did it boot up? No, it didn't boot up. Of course it didn't boot up because at the time it was still missing these key resistors right here. And you can see some craziness going on here. What's going on here? So let's look. There's supposed to be 1, 2, 3 components that live right here. Let's see what they look like in ZXW so we kind of get an idea of who they are. So let's head over here to backlight driver, and there's 1, 2, 3 components. Now, capacitors you can knock off in a data recovery situation a lot of the time, but not resistors. Resistors, if they're missing, you definitely know you have an open line because you have deleted an inline component. So who are these guys? So both of these were completely missing off of the board, and in fact, the trace here was indeed broken so that they were even missing the ability to attach to the board in general. So who are these guys? So this is R0302 and R0303. Let's see what are the consequences. Maybe there's some kind of camera or we don't really care, but let's see. R0303 and R0302. Let's head to the schematic and ask that question. Show yourselves. Let's see. All right, so here we are. Here is R0303 and R0302. And we can see that they connect this top line 1V8 and a bottom data line that's really important. So this is fide, the CPU. CPU outputs on channel I2C or I2C0, clock and data. So the way that these two data lines work is that they receive a voltage from that top 1V8 through the resistor. If you delete the resistors, then you cannot generate any signal on these two data lines, clock and data. So that's going to be a really big deal, because that means that you have just gone out of the CPU on those lines. What's the consequence of that? I don't know. Let's do an experiment. Let's take a perfectly working iCloud locked 6 Plus and let's delete those resistors. And guess what? It turns into a brain dead phone. So that would be a phone that just goes to less than 100 milliamps on DC current. And that's exactly what this phone was doing after we cleared that short. So we know, all right, the phone became an 80 milliamp phone after we had deleted the short. So why isn't an 80 milliamp phone brain dead? Well, I don't know, but one reason it's definitely going to be brain dead as long as those two resistors are missing. But here's the problem. We can't just stick them back on because of their physical presentation, right? So let's see, let's go back to ZXW and remember, where did those suckers go? So on ZXW, R0303 and R0302, they've got the data. This one has the data line connected to the top pad and the source 1V8 on the bottom pad. The other resistor also uses that source 1V8 and connects to the other data line. So both of those need to be connected to 1V8, and then each of them needs to be connected to their own data line. But the problem is that right here, this 1V8 was broken. So when I first just kind of put them on, no change. Nothing happened at all. And then I had to measure and see, oh yeah, there's 1.8 volts here at C1. Let me show you what that looked like on the actual device. 1V8 was present on the pad here, C1. Here we go, C1. We had 1.8 volts there, but it doesn't, see how you can still see the trace is broken. So it did not connect to this pad. And of course, it also didn't connect up here to that pad. So both of the 1V8 pads were 0 volts. So what did I do? I did a creative solution here. Let's walk through it. First thing I did was I made a jumper here to extend 1V8 back to its native trace so that it supplies 1V8 to this bottom pad of the first resistor. And then I got a resistor and stuck it on there. So that heals the first of these I2C lines. I forget if this is the data or the clock. I think that one's the clock. Could be wrong. So that's then, in theory, healed. But what am I going to do about this one? So I could just try putting the resistor on here and connecting it there. And I tried a few different things, but I kept troubleshooting and not seeing a response. And I wasn't really sure why. So I decided, let's clarify the picture. Let's eliminate variables. So what else could we do with this pad missing entirely for 1V8, and I'm just not sure about this I2C pad. I'm not sure if it really connects to where it's supposed to go. I tried measuring around continuity to see if that was the case, and then I decided on this solution. So let's show you what I decided to do instead. So because it was difficult to place this resistor here, I mean, I did it a few times, and then just to kind of clear the picture, I said, well, where else does that data line, I2C0 SDA, it also goes down here to the bottom backlight driver, which was also removed, which means this pad here, A1, is the exact same line. So just to simplify things, I seated the resistor in lieu of putting it here in its native position. I just did the exact same thing but moved it down. So I stuck the resistor on this pad, and then I made a jumper around to another source of that same 1V8. Hopefully that makes sense. Let's go see what it looks like in practice. And let's cruise on down here. And now you can see it. There's my resistor that I've placed here on the SDA pad of the other backlight driver. And then I made a similar jumper that tied it into 1V8. So now I have solved that problem. I have restored those two really key data lines. Now I knew those were key from experience because I've seen lots of devices where I know for sure experimentally that if you take one of those guys off and you make a brain dead phone, this was a brain dead phone, those were missing, this was a no-brainer, got to put them back. So we put them back, and guess what happened? The phone didn't boot. Of course it didn't boot. Nothing's ever easy, right? So in fact, just to be clear, the phone as we stand here now is still not booting. So we're kind of leading to where we are right now with this repair. So at that point, though, I was able to get the phone to have a fairly classic brain dead presentation that I recognized as these resistors were intact and everything was working, but it was still brain dead. Maybe it was brain dead because it was auto booting to DFU. So I ruled that out by being sure that I had a good connection to USB. So I had to do some rework down here at the charge port connector to make sure that I actually had a good line from the charge port where I'm connecting to the computer through, everything looked good over here, all the way up through to TriStar, which I changed just kind of as an oil change. And I changed Tigris and eliminated the variable. It looked like there could have been a little crack in that MOSFET, so I made a jumper there to replace the function of that MOSFET. So then I knew for sure that USB signaling was completely intact. That did not allow the phone to be detected by the computer, which means brain dead, but not because it's auto booting to DFU. The computer would have detected it, but it didn't. So what else could be a reason? We need a mechanism. How did it come to be this way? Why is this phone brain dead? Now we're always afraid that the reason is because the CPU is dead. And I know a lot of you guys are asking on the last video, and I'm sure on this one as well, the question we hear all the time, which is, Jessa, why don't you just transfer the chips on? You're doing all this work. Isn't it easier to just transfer the chips? And the answer is no. And here's why. In order to just transfer the data containing set of chips that have to work together to decrypt and present the data, then I would need to transfer the NAND, which is perfectly doable. I'd need to transfer the AP EEPROM, which is tiny, and if I don't lose them, it'll be all right, but perfectly doable. And then I need to transfer both the CPU and its double-stacked SD-RAM. And if we look at this on an angle, you can see that the CPU is really two different chips that are soldered together with underfill between them. That is a challenging but doable job. But it's not one that for this particular CPU, it's usually a very low yield job. Now, why is that? And here's why. Because when the phone doesn't turn on, when the phone doesn't turn on in a brain dead state and you've ruled out everything except for CPU, the problem isn't that the CPU is somehow disconnected. The problem is that the CPU is dead. And here's why. We know that the majority of the damage here occurred at the backlight driver. And what does the backlight driver do? It produces 22 volts. That's a big deal. We know that this phone died probably with the screen on. It was underwater actively taking pictures. We see an enormous amount of damage very localized to this backlight driver. The screen was on. So that means that the live 22 volts that was here under this chip may have, through a grain of salt, bridged into any one of these connections. And that gives us a mechanism for how we could have killed the CPU electrically. And we still don't know whether or not that's the case. It may very well be the case. So there's not really anything that we can gain by taking off the CPU and putting it onto another board, because that introduces a lot of variables. Let's look back at ZXW to just say, what does it look like under one of these CPUs in the A8? Now, if this, just to be clear, if this was an iPhone 7 or an iPhone 8, then transferring the CPU would be a good strategy because of the way those phones get damaged. They get bend damages, CPU pops off all the time. So, but not for the A8. It just isn't a failure point. And that's where physician mindset and history, how do these things tend to go wrong, rather than engineering systematic approach, tends to lead to a higher success rate. Look at the pitch of these tiny little connections that are under the CPU. Plus, this CPU has to balance on each one of those pads. The pitch is very tight compared to normal chips. So you can't have any small accidents or bridging without killing the CPU. And then you have to solder the SD-RAM on top, which means you have to prep the top of the CPU to accept the SD-RAM. That's doable, but it's a really technically challenging for the A8 CPU in a way that the current CPUs are much more straightforward. You don't have to split apart the RAM and the CPU. You can just take it as one piece. For A8, it just doesn't make sense. It just introduces way too many variables. So in order to actually go through with a strategy, that's the sort of board swap strategy, you would have to transfer intact, no damage, the CPU, its stacked RAM, plus the NAND, plus the EEPROM to a receiver board, and that would all have to work. And I'm hoping to convince you of why that would be not your best strategy and really not a feasible strategy at all. If that CPU is dead, it's going to be dead due to electricity, not due to corrosion. It's really well protected. There's no way that water actually got under there and bothered anything, at least not in my experience. So where are we with this story? We've got a brain-dead phone at that point where we've restored the I2C signaling. We've ruled out, any kind of USB connection. So therefore, we've ruled out that it's just auto-booting to DFU asking, for it can't talk to the NAND or something like that. We've ruled that out. So what's left? Well, we're going with this idea that maybe we had disruption of our I2C signaling from an original insult where that live backlight driver 22 volts was bridged into something around there. So let's see, where else do those I2C lines go? Let's head to the schematic and find out what other possible chips might have been on the receiving end of a punch in the face on these I2C lines. Also, do not comment about how I should say I2C, because that's just not how I roll. Now, let's see, where does this line go? So let's follow it. So from the master CPU, we've got signaling out, and where are the destinations? Here's one. This line goes to this guy right here, and this is the power management chip. All right, so the power management chip itself could have been electrically punched in the face if there was a surge voltage on that data line. Where else does it go? It goes over here to Chestnut. All right, so here it is at Chestnut. Damage to Chestnut then could mean that the signaling on these I2C lines was in fact scrambled due to electrical damage within Chestnut. What else? Backlight driver already removed. We've already eliminated that. What else? Chestnut. What else? TriStar. We've already changed TriStar, so we've already eliminated that. And that's it. So this line then goes from the CPU to power management, Chestnut, backlight driver, TriStar. We've changed TriStar. We've eliminated backlight driver. And that leaves Chestnut. And indeed, Chestnut was a problem. So Chestnut, you remember, on this board was underfilled. So it didn't get killed by water. However, I felt that with the way the current consumption looked, that I should be able to see an Apple logo flash at least, and I saw no image. So that was another sort of thing that pointed to Chestnut malfunction. So I went ahead and I replaced Chestnut. So let's look at that. Chestnut was underfilled on this board, which is unusual. So here's the new Chestnut. So I had to dig out and take away all these variables around Chestnut. So I got rid of the strobe driver. I got rid of all these guys around here, and then I had to put back a couple of important dudes there. But this is now a new Chestnut. And guess what happened? Guess what happened? I'll show you what happened. The answer is the phone did not boot, but I'll show you what happened. The phone will do this. So this is where we are now, and maybe you guys can help me out with how we should proceed. So let's see, where are we now? All right. She waited 4 years already, so a few more weeks is nothing. What are you talking about? I don't know. Can you start another YouTube channel just for this particular board? I'm going to say no. Although I can definitely see that when Lewis's channel was about this size, that he did do that. He kind of turned it into his live channel, which was long format, and then he would edit videos and make short format ones that kind of were more general audience. I don't think that he also doesn't have 4 children, so I'm not sure that I have the wherewithal for that. All right, so now what's going on? We have connected, let's move this over so that I can see what you see. We've connected just a charge port, a battery, and a screen. Now remember, we have no backlight drivers, so we have no chance of backlight, but we might still get image. So what we're gonna do is we're gonna put a little light here and kind of be a DIY backlight. All right, now let's prompt this phone to boot. So let's see, what can it do now? It's missing a lot of stuff. I don't know. Let's find out what does it do right now. And look at that, Saltwater phone has an Apple logo. Wouldn't it be great if it would just boot right up right now? Come on, buddy, boot up. Show us the money. Ah, my Apple logo went away. It's the worst. It's boot loop, short boot loop. Ah, short boot loop. Short boot loop. I hate you, short boot loop. Look at this, Apple logo off. Oh, so what does this mean? Well, my first question is, Jessa, you took a lot of stuff off of that board. Are you sure that you can delete all that stuff and expect that phone to boot? I don't think so. And how do you know? What would you do? What kind of experiment could we do to ask the question? Can we take all that? Can we really delete? I mean, look at all that stuff that's gone off that board. It's missing entire connectors. It's missing all of that backlight stuff, and it's missing all kinds of dudes. Well, of course it's not going to turn on. Don't be so, hopeful. Well, let's see. What I did, I'm pretty confident, just from experience, that finding of short boot loop is an information problem, which is really scary, and I don't like it at all. To me, that means all the power systems, all of the data signaling is all fine now, but the information is not there. So the board is trying to boot. I got everything I need to turn on except for where's the instruction manual? What do I do after this part? I don't know. Quit. That's what boot loop means. It's an information, kind of a data problem rather than a power problem in my experience, which usually means that this phone is going to have to pass an update, and that really stinks. But let's be sure by doing the following experiment. Maybe we're wrong. Maybe there's something that I took off that if I just put it back on, it will boot up. I don't know. So let's do this. Let's take another board. Let's take a perfectly working iPhone 6 Plus iCloud locked board. So we're going to take this board and we're going to do the following. Let me show you what I did to put a hurtin' on this board. So on this board, I did the exact same thing on this fully working board. I deleted the same caps. I took off both of the backlight drivers. I even recreated the weirdo, here's a I2C resistor kind of stuck up in the air with a wire going here. Here's the other one going there. I deleted this same connector. I deleted these same chips. I replaced chestnut. I even went further than the other one. I deleted some stuff around here. I left the same TriStar, and I didn't bother to change those guys. But I deleted baseband power chip. I deleted all these caps that, remember, in our board look really ugly, so I just deleted them in this board. And then over here, I deleted some of this stuff up on the top, because why the heck not? If you're going to delete stuff, let's really do it. In fact, we could take off all of these chips because they're no longer getting power because we deleted the baseband power chip. So we could kind of slide this whole board. In fact, I did delete speaker amp and I deleted vibrator mode. I deleted the crap out of this board. Look at this. It's just missing all kinds of stuff. Deleted everything up here just like in the other board. So everything that's missing on the Saltwater board is also missing on this board and more. So what happens when we try to boot up this board? Will it boot loop just like our Saltwater board, or will it boot? Let's find out. Let's do the experiment. Let's find out. So we're going to ask this board to boot in exactly the same way. All right, we want to see even the ones that don't work. Well, it's really kind of boring. Like most of what we do, we either instantly discard as that's a software problem, nothing you can do, like, you know, like a boot looping phone. Okay, what's wrong with it? Did it have any kind of water damage? No. Does it have any kind of electrical damage? No. Okay, then it's software corruption. Nothing you can do. Or it's ones that we pretty readily solve. These ones that take kind of a couple of sessions are, I think, the fun ones. But we don't see a ton of these. I mean, we don't see a lot of people that have a phone 4 years ago that got damaged. So let's see. We have the same scenario. Since this phone also has no backlight drivers, then it is not going to show us any light. But let's see. All right, so we plugged this in the exact same way, and we see an Apple logo. Now, let's watch this phone, the iCloud locked one, with all of this stuff taken off. Will it boot, or will it loop? Will it boot? Oh, scared me there. Didn't you see that? That's a heart stopper. But he got back on the horse. Keep going, buddy. You can do it. Boot on up. Will it boot, or will it loop? Let's see what you guys think. All right, let's see. Don't forget to like and subscribe. Yes, exactly. All right. When is part 2? This is part 2. What are you talking about? Look at that! It booted. So what do we know? This is our heavily intentionally damaged iCloud locked iPhone 6 Plus that is booting. It's actually charging. And now we have proof. We have proof that there is no legitimate reason why Kelli's Saltwater damaged board shouldn't be able to turn on. It should be able to. It has no reason. It has no further hardware damage. Let's look. Let's just be really sure. And let's take a look real quick. And I'm just about getting low on time. But as we really look at it, and we're looking for hardware damage that's not addressed, it's very minimal. We have deleted or replaced pretty much everything on this board. Well, I guess we still have, those caps back there, but they all hold the right voltage. We could delete them, but I don't think it's going to make a difference. We have really eliminated as many variables as we can that leaves us with one thing, which is we know that there was some I2C struggle, because we know that when we replaced the underfilled chestnut, the phone woke up and had image, whereas before it didn't, and water did not go under chestnut. So chestnut, we know, was electrically damaged. So that leaves us with the question of whether or not the CPU itself was electrically damaged, because it's also on that same line that we know must have received an electrical insult. Either that, or we may have data corruption within the NAND. Maybe it had fluctuating power at some point. Maybe it lived with some, corrosion under backlight driver that created data corruption that now has filled up an error log on the NAND. We don't know. But right now, this phone's problem is definitely data corruption or software. It's in the space of software and data structure. Now, here's where this is really a challenge, and this is why this now becomes a right to repair issue. What I want to be able to do, the best thing for this phone and Kelli's data, would be for me to ask this phone to update to iOS 10, which is what it was last on. What I don't want to have to do is ask the phone to update to a 2 years down the road iOS 13. It can't do a 13 because it's a 6 Plus, but the last one, 12.4. I don't want to ask this phone to have to to image the data and then plug it into the format of 12.4. I don't want to ask it to make a big jump. And here's why. Because we know that if there's a phone on iOS 10, like this one probably is, and we ask it to go to 13, what happens? It has a software incompatibility with the speaker amp. So I don't want to do that, but I don't have the tools that I need. Apple does not sign the perfectly working, nothing wrong with it iOS 10 anymore. I'm not allowed to put that on this phone. That's really unfortunate because now my hands are tied. The only thing I can do now with this phone is I have to ask it to pass an update to 12.4, which is a big jump. That's going to be hard on this board, and I don't know if it's going to be able to do it. And it really stinks that I'm not able to just ask it to just kind of update to iOS 10 or something that I can use, right? So that really kind of stinks. Now I might be able to try to check rain jailbreak this phone and see what we can do. But first, we're going to take the next step to rule out a problem that is sort of the lowest hanging fruit. We're going to ask this phone, can you pass an update? And can you update and get to iOS 12? And maybe you'll be fine. All right, so that's what we're going to do. That is the next step. It is time to ask this phone to pass update, which will correct a software problem that doesn't have anything to do with the actual stored pictures, the user data, where the problem is just corruption of some part of the iOS that's making it boot loop. So I believe that we have cleared all hardware problems, and hopefully with this other board I've convinced you that if this other board can boot with pretty much nothing on it, that it's far more straightforward to just sort of delete bad stuff, leaving behind the skeleton board, than it is to try and transfer chips that really don't have a mechanism for themselves to be damaged. But we'll see. We'll see if you guys are convinced or not. All right, so now here is Kelly's phone. And now I need a way to get it to go into recovery mode. All right, so let's see if I can do that. So that's a little bit of a challenge because I have to kind of mechanically figure out how to boot it at the same time, connect to USB, and at the same time press the non-existent home button. So how am I going to do that? Well, we can look up on the schematic and see, well, home button, there is no home button anymore, so what are we going to do about that? I am going to see what happens if I, let's see, well, it looks like a bit of a spec that I don't remember. Let's get rid of that. All right, so, yeah. Home button goes to that capacitor, and we'll touch that to ground. All right, so I'm essentially virtually pressing the home button. I'm kind of curious. I bet one of those new DFU dongles would probably work. And now I'm pressing that. I just connected to USB, and I just heard doot, 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 doot. I heard the computer detect the device. So now let's kind of look and see what does the display look like. It's probably in recovery mode. That's really the only explanation. And there, indeed it is. All right, so now this phone is, in theory, it's connected to the computer and it's in recovery mode. So let's ask it to update. So we're going to hit update. Your iTunes will update your phone to iOS 12.4 and will verify the update with Apple. Now, I don't think there's any way for me to sort of share with you guys how this is going, but right now it is extracting the software. I don't think that there's a way to kind of see that, but we will kind of put a light here and we're going to watch. This phone is either, and I don't know what's going to happen. It has a chance. It has a chance of being able to pass update, in which case this phone is going to chug across the little status bar all the way across, and it's going to update, and it's going to be able to map Kelly's pictures to their new home in iOS 12. I don't know. Let's see. Or it's going to fail. It's going to fail to update. Ah, and it failed. Error 9. So error 9 is one of the big, broad errors, right? You can look on my channel for another error 9 video, but let's try it again. Error 9 can be caused by connection problem, although that's unlikely. But let's see what happens. So let's ask it to try again. So error 9 is one of the ones that's just user data partition corrupted. So when encrypted data is corrupted, there's nothing that you can do. The data is encrypted at the level of the file system. Each file is encrypted, and if it cannot get past an update and map all of that into a new bootable structure, there's nothing that you can do. So let's give it another try. We're going to say update, update. One thing that we've been able to prove in the past when we've done experiments, what can we do to induce error 9? One thing that we can do is we can, if we damage the EEPROM chip, which this phone doesn't have a damaged EEPROM chip, but if you do, then you can trigger error 9. Error 9 is going to happen anytime the device is trying to pass an update and it needs some information that it can't get. So let's give it another chance to make sure that it didn't just become disconnected. So I'm going to be really still and let it try to update. I'm hearing a lot of connect, disconnect. And let's see, if it never even starts the status bar, then that means it really is not able to do anything. All right, so this to me is not recoverable, Kelly, with today's technology. Now, I will try a couple of last things. I will try to check rain this device and see if we can kind of clear this error and get it to be able to pass an update somehow. It's not going to be able to pass check rain, but that may clear the problem and allow it to pass update. So we'll kind of rule out some extra things. It might be worth it on this one to reball the NAND itself, just because the physical presentation is kind of ugly in there, but I don't think that's the problem. What I think happened is I'm pretty convinced that there was a 22-volt insult to the I2C lines. We know that's for sure because it killed Chestnut, and replacing Chestnut solved, and the phone had a sort of I2C. This phone does. A phone with no flash memory at all will show Apple logo, just exactly like this. So there's something that is preventing, and at the information level, that's preventing this phone from being able to listen and communicate between those key chips. In my opinion, it's electrically damaged big chips, it's electrically damaged CPU, or it's going to be damage, to the structure of the NAND, because it looks really ugly back there. And I think that's the end of the line. What we can do is ask the, let's just we can look at the log really quickly. So let me just look at the log. Let's see. Is this stream active? Hard to tell, because it looks like, oh yeah, greetings from Bolivia, Beatles number 9. Try a different cable. Well, we can do that, but the way we rule out things like cable is we're constantly updating and restoring phones, so we'll figure out really quick today if there's some kind of a cable problem. But I do want to look at the log. So let's see. I don't think that I'm set up to share the log, but maybe it will. Let's check. So we're going to look at, what did iTunes tell us? Did it give us any clue about this particular error 9? So we're going to look for iTunes logs. So Apple Computer, iPhone updater logs, and the most recent one, log file. Let's see if I can add this to, let's see, can I window capture? Can I add a window capture? Let's see, window capture. Can I add iPhone updater logs? Can I add this log? Yes. Yay. All right, so here's the actual log so that you guys can see it as well. All right, so let's look at this log together and see what it says. All right, let me get to that. Glad I can finally catch one of your strings. Thanks, Sari, for the $5. Okay, now let's head over and look at this log. Where did it go? Here it is. All right, so let's kind of scroll down to the end. Ah! Did I just close it? That's going to stink. Ah! Where is it? There it is. Okay, so let's scroll to the end. And it says, failed to receive message from device. Might be connection problem with USB host. Changing state from restore to error. Failed with error 9. Let's see, does it go back? Let's see. We're going to scroll back a little bit. So I've got some other videos on how to interpret these logs so that you can kind of see what's normal and what's not. So a lot of this is normal. Then it kind of starts these checkpoints, checkpoint, 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 update, and then that all looks, you know, relatively normal. And then found iBoot, that's pretty normal. It doesn't mean that the device disconnected. It could mean that, but really what it means is I needed a key that this device could not produce, so I kicked it out. And then it writes that down as device disconnected, device removed before restore completed, right? And we can prove this by taking a working iCloud lock device, crushing the EEPROM, which needs to provide one of those keys, and then it will say that exact same thing. All right, so failed to receive message from the device. Yeah, so that's what it means. Failed to receive message from the device. I asked this phone to tell me something that he was not able to supply the information that I needed to hear in order to go through with with imaging the data and decrypting it. So that's the deal with that. We will kind of do like a little bit more with it and just make sure, try it a few more times, move it around a little bit and see if anything clears up. And we'll definitely report back. It is possible that there's like, you know, maybe this charge port kind of got bent a little bit in the last day. Totally possible. So we will kind of leave no stone unturned. And if this device ends up recoverable, we will let you know. But as far as I can tell, I love the story of this one. It teaches you a lot. And this is how we think about iPhones. And this recovery, if successful, would cost the same $300 that one that we just kicked the cap off is, right? And this costs Kelli nothing if we can't get her data. So I think that it was that was really the very best chance for this device. And there's no indication in my experience to guess that there's any kind of a connection problem that would mean that transferring the CPU and the NAND and the EEPROM to a receiver board, it's not going to make any difference in my experience. So I wanted to kind of address that with you guys that are always suggesting that we do that. Can you check I2C, SDA, and clock? Yeah, I've already done that. So those are all showing the same communication as far as we can tell. I didn't check it with an oscilloscope. I wouldn't know what it meant either, right? But they are electrically active. They both have voltage. All right, not enough rice has been used. Okay, and now it is time for me to run out of here, and I will see you next time. So I hope that you guys like this sort of long format content. I'm not sure how often we'll do sort of long involved ones like this because they are pretty specialized. So let me know if this is something that you enjoy seeing on the channel, or if you prefer sort of the kind of short ones that get an answer really quickly. And thanks for watching. I'll see you next time.